Hello friends, today in this video we are going to learn how to repair a new generation laptops. In new generation laptop there is no PCH, only CPU is there. So that is the main difference, and the another difference is in the previous older versions of laptops there is a 3 and 5 volt section which combined 3 volt and 5 volt chips, but in here the new generation, so there is a separate chips for the 3 volt and the 5 volt. Within that chips there are the both section like the linear regulator as well as the buck converters are inbuilt in the chips. Okay, so that is the main difference. And instead of PCH, the CPU and the PCH is combined into the single chip. This chips is basically, it's called the SoC. SoC means the system on the chips. Okay, so we'll start how it's work, and then we'll see the flow charts. If it is red, then how to follow the signals, how to follow the paths. So first, so this is our adapter inputs and battery charging section, so we call it A sections. Then this is our always voltage section, or the 3 volt and 5 volt section, we call it the B sections. And this is a C section, is basically the power on section, where the CPU and the SIO will communicate with each other and generate the power, turn on the power. So like that, the SIO will coordinate with the CPU. The CPU have its own power management department, and the SIO communicate with power management department and turn on the system. Now this newer generation's laptop, the EC bias is inbuilt into the SIO. In the previous versions of laptop, there is a EC bias is a separate chips. Okay, it's a 8-pin chips, but in the newer laptops the EC bias is inbuilt into the SIO. So there is a separate programmers for to flash this EC bias. We can use SOD3 or ENIT programmer to program SIO. So there are varieties of programmable chips that you can see in our another video. So let's start how this functions and how the signal flows. So first, when we connect the adapter to the DC jacks, then my voltage will flow from this MOSFET to this MOSFET. This is the current sensing resistor, and my voltage will travel from here to here to here, like this. You can see in this animation how the voltage is flowing. Okay, so when I connect the adapter, it will flow from here, like it will communicate with this battery charging chips. Then battery charging chips will drive this two MOSFETs, and my voltage will be traveled from here to here to here, and it goes to this 3 volt and 5 volt chips. So this is a single chips 5 volt as 3 volt, and this is a single chip 3 volt, and it's basically going to the entire motherboard, like all the buck converter. This is the current sensing resistor is basically a junction from where the voltage travel to the entire motherboard. Every buck converter get the input from here only. Okay, so you understand that. But in this screen we are going to discuss only 3 volt and 5 volt section. We are not discussing the other section, because the rest of the sections will work after power button press. Okay, so this 3 volt, this 18 volt or 19 volt, whatever the adapter voltage is input there, that will travel from this path and it goes to this 3 volt and 5 volt inputs. So as soon as get this inputs to its V-in pin, both the chips, 3 volt and 5 volt chips, and once they get the enable signal, because there are two enable, one enable for the linear regulator and another enable for the buck converter. So for the linear regulator, the enable is coming from directly from here only, like this here, suppose this, if it here 18 volt, and from here in circuit they put one resistor, and from this resistor the voltage is divided and goes to this enable pin, and it's enable. And so once this chips get the enable, then this 3 volt, this linear voltage will be generated, that is called the LDO, or it's called the 3 VLP. 3 VLP means 3 volt linear. Okay, so this 3 VLP voltage will come out like this. Okay, it will come like this. So once you get the enable, then 3 volt will come out, and this voltage goes to the SIO. SIO get the power. That's step number 3. So you can see in this sequence, or in any of our other videos also, we give you the step-by-step signal. All signals come one after another. So student, it's very easy to understand you. So just simply you follow the steps. So once you follow the steps, you can understand the concept very thoroughly, and you can able to repair any kind of laptops. Okay, so the third step is that you have to check that is a 3 VLP, and this 3 VLP, that is a linear voltage output, will goes to the SIO. It's SIO VCC pin. Okay, so you have to check this 3 volt. If this 3 volt is not coming, then you have to go back, check this IC, check the input, check the enable. If both the inputs and enable is coming but still output is not coming, that means this chips is a faulty. Okay, and if one of the inputs is missing, then you have to find why these inputs are missing. So you have to check that why it's not coming. Okay, so the chips will get this 3 volt. The chip will start. Now this SIO need one more signal, that is called the EC reset. EC means the embedded controller reset, and here is the RC circuit. It's called a resistor and the capacitor circuit. So this is basically the RC circuit, resistor and the capacitor. Okay, so it generates some delay circuits. Okay, so what it generates? Some delay circuit, and that delay will generate a 3 volt, and 3 volt is coming to its EC reset pin. EC reset is embedded controller reset. SI will get the reset. SI will come out from the reset states, and it start functioning. Start reading the BIOS. Now the EC BIOS is inbuilt into this chips. This chips number is KB9022. So the SI will start communicating with the BIOS and is ready to work. Now you check all the rest of the signal, like lead switch or the thermal trips. Both signals should be the 3 volt. Lead switch and the thermal trip should be the 3 volt, and AC in signal that is coming from here, coming from the battery charging chips, it will also goes to this SIO, and that signal also a 3 volt. Okay, so once get all the signal, that then the SI is ready to functions, and then he's wait for the step number 5. The step number 5 is a power button. The power button is basically called, the different names are given, and the different models. So the power button names something called NBSW power on, or power button, or the power switch, or on off, something written on the space, because this is a 128 leg chips. Each legs have their own meaning and own purpose. Some pins are inputs, some pins are outputs, some pins are power, like that. So this is a power switch. It's called the NBSW or on. So this is step number 5, and you will get here a 3 volt. 3 volt is coming, and once it press this button, it goes to 0, and when we release this button, it go back to 3 volt, right? So at step number 5, we'll press this power switch. It goes to 0 volt and come back to 3. Then this SIO will get one pulse, that is a 303 pulse get. And once he get this pulse, SIO will come to know that the power button is pressed. Now what he will do is, he generate one signal that is called the EC on. Now the EC is ready to work. EC underscore on. Okay, this is step number 6. And if this signal is not coming, then you have to check this SIO. SIO is a faulty if the EC on signal is not coming after power button press. Okay, so the step number 6 is EC on. EC on will generate a 3 volt, and this 3 volt drive to this both buck converter, and this buck converter will get enable signal. I already told you this buck converter have 2 enable pin. One enable pin for the linear regulator and another enable for the buck converter. Now EC on will turn on the another enable signal, that is buck converter. The buck converter start functioning and generate a 3 volt always. Okay, so here is also 3 volt, here is also 3 volt. This 3 volt is for the SIO when the power is off, and this 3 volt to the CPU as well as to the BIOS as well as to the rest of the circuit. Okay, so this is a buck converter output and this is a linear regulator output. Linear regulator has some capacity, have a very less current, less than 500 milliampere, but the buck converter have the capacity, have the 10 ampere current. So there are provide to the different chips. So this 3 volt will be generate and 3 volt is goes to the CPU. And which pin it will go, because CPU have so many pins, right? So it will goes to the VCC DSW 3_3. Okay, so you have to check this VCC DSW 3_3. That is the step number 7. Now the CPU get the power. Okay, now CPU is ready to work. But before that, CPU needs some voltages and some criteria. And what are those? The criteria, that is CPU should get the RTC reset. Okay, there is a CMOS battery. This is a 3 volt CMOS battery. Okay, and CPU should get this RTC VCC 3 volt, and there one more reset signal is called RTC reset. It's like EC reset is here, so reset the SIO. Similarly, the RTC reset is a reset the RTC circuitry. So this signal also require, and this both signal should be a 3 volt. RTC VCC should be the 3 volt. RTC reset should be the 3 volt. If one of the voltage is 0, then CPU won't turn on. So remember that. So both signals should be a 3 volt. Okay. So now RTC VCC and RTC reset is a 3 volt, and when the CPU get this power, CPU is ready to work. Okay. Then the next signal that SI will send CPU to the DPWR OK signal. That means as I was saying to the CPU, I am ready to work. This DPWR power OK means this power is stable. If the CPU is OK from his end, then CPU will generate this PM_SLP_sus. That means CPU acknowledge that I got the suspend power. SUS means the suspend power. CPU got this suspend power. Okay. So this is step number 9. You should get a 3 volt. You can check all the signal from toward the SIO side. You can't check all the signal to the CPU because the CPU is a BGA chips. So you can't check all the signal on the CPU. So you can check all the signal on the SIO pin. So you have to check this SLP_SUS signal. After that, CPU send one important signal that is called the RSM RST. Okay, RSM resume and reset. This one more reset is signal to the CPU. It's called the RSM RST. Okay, so SI will generate the next signal that is called the RSM RST. So you have to check this RSM RST signal. If this voltage is not coming, then you have to check the SIO pin, something problem in the SIO or something problem in the EC bias. Okay, so maybe first you have to flash the EC bias and check, and if not problem solved, then you have to replace the SIO and reflash the EC bias. Okay, so this is very important signal RSM RST. Of course, all the signals are important and all the signals are coming one after another. So after that, there's a 11th signal that is called a PM power button. The PM power button or the PBTN out. The PM power button or the PBTN out is a digital power output. Okay, digital power button. This button says to the CPU that the power button is pressed. Okay, this power button is a manual power button where the user press the power button, and this power button is a digital power button where the SIO informing to the CPU that the power button is pressed. Okay, so this is a step number 10. Okay, so you have to check 303 pulse will be generated. Okay, so this is a step number 10, that is PM power button or the PBTN out. Okay, so you have to check that. After that, CPU get this PBTN out from the SIO. CPU has to respond. CPU has to respond to the SIO and generate this two signal. Is called SLP underscore S4 and SLP underscore S3. There are so many power states in the laptop motherboard. One is called the G3 states, then the S5 states, then the S4 states, then the S3 states and the S0 states. So these are the different stages of the power where one after one the powers gets turned on. So you can see what are the power states in our another video. So now the CPU send this two signal SLP underscore S4 and SLP underscore S3. So you can check the signal on the SIO pin 3 volt, and if this 3 volt is not coming from the CPU, then CPU is a faulty. So you have to check the CPU is a bad. You can check the sys clock also. So once it get this power, then CPU generate the sys clock. Sys clock you can check with the help of multimeter, or you can check our logic analyzer, which is a helpful device, which is a very cheap and which is a very helpful device to check all the signals. So in multimeter you can check the voltage level, but you can't check the signal level. So to check the signal level, you need a device like oscilloscope, or you need signal analyzer, where you will get some frequency that is a 32.7 kilohertz. You will get a 32.7 kilohertz frequency. Okay, so you can check that SLPS3 and SLP signal is not coming, then you have to check the CPU may be faulty, you have to check that. So if both the signals are coming from the CPU, then next thing is the SI is ready to work, and he turn on all the buck converter one after another. So there are so many buck converters there in a single motherboards, and there are so many power level like 1.05, 1.5, 1.35, 1.8 CPU core, and all the different voltage level are there. So SIO will generate one signal that is called a system on, okay, and suspend on. The system on signal turn on the RAM supply, whichever RAM it may be DDR4, DDR3L, whatever it is. So if it is a DDR4, then it turn on the 1.2 buck converter, and if it's a DDR3L, then that buck converter could be 1.35. So sys on signal turn on the RAM supply, SUSP turn on 1.05, 1.8 and 3.35 suspend supply generate. So that is the step number 13. Okay, and next is the EC key KB reset will be generate. Okay, and at step number 14, SI will get the information that 1.05, that is the 1.05 VS underscore PG, that means the 1.05 supply is stable. That means now all powers are okay except CPU core. That means in motherboard turn on the all supply like 1.05, 1.35, 1.5, 1.8, 3.35, all voltage are stable. This signal indicate that all voltage are stable. Now only one voltage is left, that is called the CPU core, and the CPU core here turn on only by the CPU. CPU will turn on his own supply, but before that he should get one signal that is called the system power OK from the SIO. The system power OK or the PCH power OK is a step number 15, where SIO inform CPU that all powers are okay. Now you turn on your own supply. Okay, so SI will generate this signal. It's called a system power OK to the CPU. If we check this signal 3 volt, that means your all powers are okay except CPU core. Now the next is, once CPU get input to the signal, then CPU will generate this signal. It's called the VR on. The VR on, that is turn on the CPU core voltage. That is step number 16, and CPU will generate this to turn on the VRM section, that is CPU core section will be turn on, right? And then the CPU core will be given to the CPU. So this is called the CPU core voltage. Okay, will be a CPU core voltage is given to the CPU. That CPU core voltage somewhere around 1 volt. Here in the CPU core voltage is not a fixed voltage because CPU considered to be in a current that is about an ampere. So here if you're going to check the voltage, then the voltage from 0.8 volt to 1.8 in between. So once you check this CPU core voltage, here voltage will be somewhere around 1 here and there 1 volt. So you have to check by using a multimeter. The next signal is when the CPU core voltage is stable, then this VRM will generate the power good signal. That means the CPU, once the CPU core voltage is stable, the VRM will generate the V gate. The V gate means the CPU core voltage is stable. That is a step number 17. The step number 17 means the CPU core voltage is stable. Okay. And once the CPU core voltage will be stable, then the CPU will generate a PLT reset. The CPU will generate a PLT reset, that is a 3 volt. It's called PLT reset, PLT, RST, and reset the entire motherboard. So friends, in this way, this new generation's motherboard signal works. So if you have a dead laptop which is not powering on, some of the reason, then you have to follow all the 17 steps. You have to check all the sequence one after another, and I'm 100% sure that you can able to repair 100%. Okay, so thank you very much.